Hey folks, I wanted to give you guys a quick lesson on mean versus median and how they relate to right and left skewed distributions. And we're going to use R to demonstrate a few concepts here. So what I did is I typed in some information here. You can see some numbers that I typed into R. And oh, by the way, I have to remind you, in order for you to do this, you're going to have to go to repl.it, repl.it. You're going to have to log into your account, and you're going to have to click on New REPL. And when you do, you're going to select R as the programming language, and then you can get here and do what I'm doing. And I would like you to be able to do this. Okay, so anyways, once you're in R, then the next thing you do is you are going to, we're making this variable x, and then I have the less than symbol and a dash. And when you put them together, they look a little bit like a left arrow. And in R, what that left arrow does is it takes whatever is here, these numbers, and it puts them into x. X is a variable. Sort of like in algebra class, x can hold some values. But in algebra class, x only holds one value at a time, like -13 or 25, or maybe even 0.147. But with programming languages, a variable can hold more than one value, or they can hold one value. But in this case, we're putting several different numbers into x. And by the way, in programming languages, variables can also hold letters and words as well. Anyways, for right now, we're just going to store this series of numbers into x, this set of numbers. Okay, so now first I want to check and see, did the numbers actually get stored into x? So in order to verify that, I'm going to use something called the print command, P-R-I-N-T, and then x. So I'm going to print out whatever x is holding. So supposedly these numbers are getting stored in x on one line of the program, and then on the next line we get to see what actually happened. So I'm going to go ahead and hit run, and the results should come out over here on the right. So let's see what happens. Here we go. And when I hit run, I see these numbers. And these numbers showed up because of this print command. So the good news is these numbers made it into x. All right, now, the next thing we want to do is we want to see if R can actually help us do some statistics. So one thing that we might like to do is we might like to take a look at the average of these numbers. And we can do that by doing something like mean of x. And let's just see how that works. So here we go. I'm printing the mean of x. So I'm going to hit run. And it looks like the mean or the average is 78 point some decimals. Okay. Now, the thing is this. I would like it, and you would like it, if we printed a bunch of different numbers, if we calculated a bunch of statistics, it would be nice to know which numbers were which. So what we're going to do is we're going to get a little fancy with our programming here. We're going to make it so that not only will R tell us what the value of the average is, we're actually going to have R tell us I am printing the average. So we do use double quotes, and then you can type really any word you want, but I'm going to type the word mean because that's what I'm about to show, and then equal and then space because whatever I'm about to show is the mean. And then after all of that, I'm going to put a comma, and then I'm going to put mean of x. So what I'm telling the computer to do is to tell me that it's printing the mean, and then to actually print the mean. Now, the thing is, the bummer is that in order to print more than one thing together, in some programming languages, sometimes we have to put the things together. And in R, we definitely do. In R, in order to print more than one thing in a row, we have to do something called concatenate. So I'm actually going to change this from a print command to a cat command. Cat is short for concatenate. And in fact, I don't think you can actually type concatenate. I don't think it'll work. Anyways, we'll do cat, and then we'll put in the mean of x. And then there is one other tricky little thing. what we'd like to have happen is I'd like to be able to print several numbers in a row, and if I'm going to use the cat command each time, I have to put that I want to go to a new line. So I'm going to do double quote backslash lowercase n, and that tells cat to go to the new line. Now, luckily, print does not need any such thing. So when we use print, it works nice and easy. The only bummer is print will only print one thing and then go to the next line. So we have pros and cons for using print versus cat. Anyways, we're going to go ahead and use cat. And since I went to all this effort to type all that stuff out, I'm going to go ahead and highlight all this by using the shift key and my arrows on my keyboard. I could have done my mouse, that would work as well. And then I'm going to do Control C to copy, and then Control V to paste. And again on the Mac, Command C and Command V. And then I'm going to change this from mean to median, and change this from mean to median. So R is going to compute for me the mean and the median for all the values in X, and it will tell me which one is the mean and which one is the median. So let's go ahead and run this program and see what happens. And there we go. So we got the mean again, and then we got the mean and we were told that it was the mean, and we got the median and we're told that it's the median. Now, finally, we're getting to the point. I wanted to get you through some little details about how to write code in R, some little tips and tricks. But now let's get to the statistics stuff, okay? Now we can begin to use R to help us better understand statistics. So, one thing I'd like to point out is that the median and the mean are very close to each other right now. They're both about 79, okay? So what that means is that this distribution is probably not left or right skewed, because left and right skewed distributions, the mean and the median, are not this close together. So what we'd like to do is we'd like to do some experiments to get a better feeling for what it means for what happens to the mean and the median when we have a right skewed or a left skewed distribution. So the very first thing I'm going to do is I'd like to show you that this distribution is not skewed. Just so that you can believe me, okay? Maybe this is not enough evidence for you that, you know, the mean and the median are close. Let's look at it graphically. Let's do a histogram. So here we go. I'm going to go ahead and add a line below that says hist of x. And then I'm going to go ahead and run. And over here I get a PDF, and I'll click on it, and I can now see the histogram, and I can see it doesn't look like there's a right tail or a left tail. It does look like it's going down a little bit to the left, but it's not really a pronounced tail, okay? And you'll see what I mean in a minute. So let's go back to our code, and let's make a tail. So first thing we're going to do is we're going to add a right tail. Now, I'm about to add numbers to the right of the numbers that I already have. That has nothing to do with me making a right tail. Why is that? Well, a right tail is always numbers that are larger than the numbers that are already in my data set. So I could add these numbers to the left or to the right or in the center. I can put them wherever I want, but they have to be bigger than my existing numbers. That's the only way I'm going to get a right tail. So my numbers are in the range of 70s and 80s. So I'm going to put in numbers like 100 and 120 and 140 and 160 and 180. And now I've begun to form a tail. And let's go ahead and see what that looks like. So I'm going to go ahead and hit run. And let's take a look at the histogram. So I'll go back here. And now we can see, oh yeah, okay, so pretty clearly there's a tail. Now, not only did I add bigger numbers, but I kind of spread them out so that they wouldn't build up very high. I'd like to remind you that the way a histogram works, and I'm going to try to make this a little bigger so you can see it. The way a histogram works is that a histogram is a single variable way to visualize data, okay? Histograms are not for working with two variables, only one. And the values of that variable are all down here. The y-axis in a histogram is always how many of these values I have. So I have an awful lot of values between 60 and 100. but I have very few values between 100 and 120 and 120 and 140, etc., etc. And for that reason, I end up with a tail. Okay, so I just want to give you some sense of how that works. Now, let's go and take a look at the mean and the median. So the median actually went up a little bit. It was 79 and now it's 81.5. But look at the mean. It went way the heck up. Okay, and that is a result of having a right hand tail. If your distribution is skewed to the right, you have a tail on the right, and it means your mean will get bigger than your median. Now, part of the reason why is because the numbers are not just on the right, they are bigger than all the numbers you had before. That will naturally pull the mean to a larger number. It'll make the mean larger. Okay. Now, now some of you might be thinking to yourself, well, 95 isn't that much bigger than 81. Well, we could put a more exaggerated tail in there. We could go put, 200, 300, 400. Now, the problem with this is that in a real data distribution, it's possible we might consider some of these numbers as outliers. It's hard to say, maybe, maybe not. And something else that I'd like to point out to you. This thing that I'm doing about adding a tail to a distribution is not something people ever do. The only reason we're doing it right now is to experiment with the effect that the tail has on the mean and the median. So anyways, let's take a look and see what happened when I added these larger numbers. I'm curious how much bigger the median gets versus the mean. Let's take a look. So I'm going to go ahead and hit run. And again, we can go look at the histogram and we can see, sure enough, I made kind of a tail to the right. But some of these data points on the right might be outliers, and soon enough we'll learn how to tell mathematically whether something's an outlier. Let's take a look at the mean and the median. The median went from 79 to 82, but now the mean went up to 124. Again, for some of you, you might be thinking, well, that's not so much bigger, but it's still a lot bigger, okay? It's about 40 bigger, so it's about 50% bigger, so it's large. Okay, anyways, enough of that. Let's be done with the right-hand tail. Let's see what happens if I make a left tail on the data. Actually, you know what? Why should I? That's your assignment. You are going to take the data, you're going to add a left tail, you're going to capture a screenshot that shows me the histogram with the left tail, and you're going to make a screenshot of the mean and the median to show me what happened with that. And then you're going to write out a few words to tell me what happened to the mean and the median when you added the left tail to the distribution. All right, I wish you luck with this task.